Good morning, good morning, good morning. David, are you here? Oh, David, yeah. Oh, there you are. Okay, so here we go. Hey, I wanted to show you guys, obviously, if you're here, you guys are probably the tech experts, but I did want to show you just so that we're all on the same sheet of music here on how to turn in assignments. So if we look at this, this would be what yours looks like. I'm actually a member of Mr. Calanella's class. So if I click on him, I can't show you mine because mine will be the instructor view. So if we look on Mr. Calanella's page, if we go up here, mine's the same way. If you go up to assignments right here, and you click on that, you can see that I've been a very poor student. I haven't turned in anything, which is why it says past due, past due, past due. If I do a click on one of the assignments right here, at the very bottom of the assignment, the assignment the instructions will say right here. On mine, right here, the link's here. If it's a worksheet, the link will be here. And then absolutely, if you don't catch my class live, then you'll see the link to the video of the class here. But this add work is what I wanted to point out here. This is how you attach homework, quizzes, or tests. You click on that. Obviously, we need you to take pictures. So at the very bottom here, it says upload from this device. If I click on that, and then wherever you guys keep your pictures, I keep mine right here. So if I want to send a horse's butt to Mr. Calanella, I just click on that. Now, granted, there might be multiple pages that you have to do that. So I click done there. You can see my butt now is attached to this assignment. So if I was a really bad student, I would turn in that picture of a butt to Mr. Calanella, which I will not do, but that's how you turn it in. All right, I just wanted to show you guys that. Obviously, if you're here, you probably know what you're doing. I'm just reading what you're saying in chat here. So we'll get to homework right now. Looks like some people have some questions on the homework. This is not what I want to see. I want to see this. There we go. All right, so you guys had the worksheet. The second thing is that today the quiz, we were going to have the quiz today. So normally if we were in normal class, I would say I'd pass out the quizzes right now. I'd say take the next 10 minutes. We're not going to waste 10 minutes of class time. Plus, some kids will want to print it out. Maybe there's a problem with printers or whatnot. I don't want to deal with all those issues. So what I'm going to tell you guys is after the class is done at some time during the day, maybe you've already done it, I want you to take 10 minutes and take the quiz. Make sure that you show me all your work. You take a picture of it. Make sure it is nice and clear. When you attach it, look at it. Make sure that you can read it, because if you can't read it, I certainly can't read it. And then attach those pictures to that quiz, and then make sure you submit that. Once that's done, then you can get started on your homework. So do the quiz first before you get started on your homework for today. Now, some of you may have already gotten started. I don't know. Already started, whatnot. Maybe some of you have taken the quiz. I haven't looked to see if any of you did that. But what I do want to ask, were there any questions on that worksheet? Obviously, the answers were there, so we're not going to go over the answers. No questions? Speak up now or forever hold your peace. Okay, no questions. We're moving on. Here we go. Let's see. Today was quiz day and 6.6. Today is an easier day than the last 2 days. The last 2 days, it was new stuff. It was, I won't use the word challenging, but it was certainly something you need to learn. All right, so here's today's homework. Number 16, I did not assign. If you want to show me how smart you are, do number 16 as well. 16 is a challenge. So the homework's 1 through 10 all and 15 through 20 all. Oops, sorry. All right, and the other thing too is that if you are catching this live, just remember that when you click on the assignment, this is what appears here. So some of you may want to write it down. Some of you may, well, it's already on the assignment. I don't need to write it down. All right, here we go. Triangles, our friendly triangle. Yeah, today's class is just on triangles. So as I said, this geometry chapter jumps around. We start off with points, segments, rays, lines. Then we jump to angles. Then we jump to circles, and now we're on triangles. All right, or I'm sorry, two lines, two parallel lines cut by transversal. The angles are formed there, and now we're on triangles. So it definitely jumps around. All right, so put this in your notes, please. A polygon, poly meaning many, gon meaning angles or corners. So many corners or many angles, a shape that has many corners or angles. This is a closed plane figure. Figure is a big fancy word for shape. Closed meaning it's not an open, like it's not a U. A U would be an open shape. A triangle would be a closed shape, meaning you can't get to the inside of the shape without crossing a segment. So it's a closed plane. Plane means it's on a flat surface. Closed plane figure with at least 3 sides. So we're talking about shapes that have 3 or more sides. And those sides are made up of segments. So no lines, no rays. Made up of segments joined at their endpoints. So you are not allowed to join your segments at anything but their endpoints. And if you do that, you have a polygon. All right, so here are 1, 2, 3 segments. If I join the segments together, I make, what the heck did I just make? I don't even know what that is, right? Why do I not know what that is? Because I did not follow the rules here. The rules said I was supposed to join the segments at their endpoints. All right, well, I joined black to blue at an endpoint, but on red, I kind of put it in the middle of the black one. I'm not allowed to do that. I'm supposed to join them at their endpoints. So if I try that again, there's red, there's blue, they're joined at their endpoints, and there's black. I make a recognizable shape. Obviously, I've made a triangle. So polygon, a closed plane figure with at least 3 sides made from segments joined at their endpoints. And there I've given you the first polygon. That first polygon has 3 sides. There are more. First polygon has 3 sides, and we call it a triangle. A triangle is a 3-sided polygon. Once again, poly, many, gon, angle or corner, many angles. A 3-sided polygon. It turns out that if you look at those 3 angles that you just made on the inside of the triangle, that they add up to 180 degrees. Now, until we get to high school, we accept that as a fact. When we take geometry in high school, I will prove that to you. But for right now, we're going to write that down as a fact, that the sum of the interior angles of a triangle is 180 degrees. There is a nifty little trick that we would do in class together, but since we're not in class, I don't do it. So you're going to have to wait until high school for me to prove you why this is true, that the sum of the interior angles of a triangle is 180 degrees. So those two facts, that a triangle has 3 sides, and that the interior angle, by interior angles, I mean this angle right here, the angle formed between blue and black, the angle formed between blue and red, and the angle formed between, red and black. If you add 1, 2, and 3 together, you get 180 degrees. Okay, so that was a lot to write down, especially if you're taking this class live. So I'll pause for a moment to allow you to write this down. Okay, good to go? Everybody got copied down? Moving on. So let's name our triangles. It turns out that we name our triangles in 2 different ways. One by their side measurements and one by their angle measurements, sides and angles. So we're going to have two different ways of naming triangles. So the first way we'll cover is by their angle measurements. It turns out by their angle measurements, we have 4 different types of triangles, 4 of them. There'll be 4 by angle measurements. All right, Jaden, you know one of them?
Sorry?
No name of one of them?
An acute
There we
triangle.
go. That's the first one we will say. When all 3 angles of the triangle are acute, those 3 angles right there, we call it an acute triangle. That means all 3 angles are less than 90, but when you add them up, they add up to 180. So we add all 3 of those angles up, we get 180, but all 3 of them are acute. That is an acute triangle. Now, you don't need to necessarily draw the picture, but you do need to write down what's in yellow. So if all 3 interior angles of a triangle are acute, it's called an acute triangle. Avery, you want to take a guess at the next one?
Right triangle?
Oh, you guys are killing it. All right. When one of the angles is right, the reason why we can only have one is because if there's 180 degrees, 180 minus 90 is 90. You're only left with 90 degrees for the other two angles. So a right triangle will have 1 right angle and 2 acute angles. Further, when it's a right triangle, you'll get a little square that shows you where the right angle is. So this is called a right triangle. Now I said there were 4 of these.
Obtuse triangle.
Oh, somebody's already taken a guess. There we go. When one of the angles is obtuse, remember, one is obtuse, there's only 2 left. So if it's obtuse, it's bigger than 90. You subtract that from 180, you just don't have enough left to either make a right or an obtuse angle. So there's only 1 obtuse angle for an obtuse triangle. So we got acute, right, obtuse. We do have one more. It's not in the book. It's called an equiangular triangle. That means all the angles are the same. I throw that out there just so that you know. Equiangular, equal angles. Equiangular triangle would be the 4th one.
Wouldn't that have to be an acute triangle then?
Have to be an acute. If all 3 angles are the same, 3 goes into 180 60 times, so all the angles are 60 degrees. That would be an equiangular triangle. Very good. Okay, we okay? Moving on. So now we're going to classify triangles by their side lengths. Turns out there's 3 of these. The first one, when all 3 sides, we're not talking angles now, but when all 3 sides are the same, anybody know? We call this a? Anybody? We call it an equilateral. Now these tick marks show that the sides are the same. If you see a tick mark, it means it's showing you that the sides have equal measurements or the sides are congruent. So we call this an equilateral triangle, an equal lateral side, equal sides. When all 3 sides are the same, we call it equilateral triangle, equilateral triangle. Tick mark means any other side that has 1 tick mark has the same measurement. Equilateral, all 3 sides are the same, equal lateral side. If you have a triangle with 2 sides are the same, we call it a, anybody? No one? A triangle that has 2 sides that are congruent. Prudence, you don't know? Breckton, do you remember? No one remembers. All right, when 2 sides are the same of a triangle, it is called, the worst one to spell, it is called an isosceles triangle, isosceles, isosceles triangle. That is a triangle where two sides are the same. Isosceles triangle. Isosceles triangle. Isosceles is how I remembered it, so I would always spell it correctly. Isosceles triangle. Which leaves us with the last triangle where none of the sides are the same. This is the hardest one to remember. When none of the sides are the same, it is called a scalene triangle. So there's no tick marks there. No sides are the same. Scalene triangle. Equilateral, all the sides are the same. Isosceles, two of the sides are the same. That's why it has two tick marks. And scalene, no sides are the same.
For some reason, scaling is the one I remember, and I don't remember the other ones.
Crazy. Now, I drew this as an obtuse scalene triangle. You can have an acute scalene triangle as well, too. You can have an obtuse, acute, or a right, or I should say, for scalene, you could have a right, you can have a obtuse or acute. Same thing for isosceles. You can have a right isosceles. You can have an acute isosceles. You can have an obtuse isosceles. Equilateral, there's only one. It's going to be an acute triangle, meaning that all the angles are 60 degrees. All the sides are the same. All the angles are the same. All right, we good to go on these triangles by angle measurements and side measurements. The first thing they'll have you do tonight for homework is they'll have you name them by both sides and angle measurements. So let's practice that. All right, so a quick note. When you see the tick mark things, one tick mark goes with one tick mark. Two tick marks goes with two tick marks. So it's saying this side, the side on the top left goes with top left, top right with top right, bottom with bottom. And they may use 1, 2, or 3 tick marks. All right, so I will give you a triangle. There it is. Let's see, by angle measurements, this is what kind of triangle? Somebody pipe up.
Right triangle.
That is a right triangle. By side measurements, notice there are no tick marks, so that would make it
Scaling.
scalene. The other way this question can be answered or asked is if they actually give the measurements of the sides, the measurements of the angles. They're either going to give it to you with tick marks or with measurements or a combination of both. All right, so by angle measurements, this is a
Right triangle.
that's a right one again. By side measurements, it is a
Isosceles.
I got 2 tick marks, so therefore it's isosceles. That's how this game is played. Okay, also can be done with measurements. By angle measurements, this is a
acute.
And it's acute. And by side measurements,
Equilateral.
Equilateral. Now I would also accept equiangular as well too for angle, but acute's fine. All right, here we go. 3 more really quickly. By side measurements, this one is a
Right.
by side measurements.
Oh.
Isosceles.
Yeah, I flipped it around on you. So it's isosceles. By angle measurements, you are correct though. It is a right. This is a bit more challenging. Well, obviously by side measurements, it's
Scaling.
There's no tick marks. It's scaling. By angle measurements, you kind of just got to look at them.
Obtuse.
It is obtuse.
Because it don't got the square thing.
Well, just remember, it could be acute as well too. So you got to look at all 3 angles. You could have a scaling acute triangle as well. But clearly, this one angle right here is obtuse. This is acute. That's obtuse. All right, last one. By side measurements, this is
Equilateral.
And by angle measurements, all equilateral triangles are
Acute.
or equiangular. Okay, very good. All right, first step, pretty easy. All right, now it comes the pre-algebra stuff. This is the more challenging stuff right here. So we know, and I just defined it for you before, that if you add up x, y, z for a triangle, just a triangle, you get 180 degrees. So we're going to use that fact right there to answer some questions. Once again, if we have a triangle, 3 interior angles added together is 180 degrees. So x plus y plus z is 180. That would be the algebra. What I will give you, the new game is, instead of giving you 3 unknown, I will give you 2 known and ask you to solve for the 3rd one. Who's got it figured out what I need to do?
You need to add the 2 sides and then subtract it from 180.
There you go. So if this is the equation that solves any triangle's angle measurements, you take the 3 interior angles, add them up, it's 180. We can plug in what we know. And what Jay says, well, what this basically tells us algebraically is that if we simplify this, we would add these two and then subtract both sides by 155. So what Jay said was take the two given, add them, and subtract from 180. That's what we just did to get to our answer.
If there's an isosceles triangle and we're only given
Yeah, we'll talk about it. We'll
okay.
talk about it. All right. So notice here, it looks like I'm only giving you one angle, but I've actually given you
2.
two because, well, this one is 90 because it's got the square. So even though it looks like I only gave you one angle, I actually gave you two. So we add 55 and 90, subtract it from 180. If you want to solve it algebraically, you plug in the numbers. Well, you're still adding 55 and 90, and then you're subtracting that from both sides. In other words, from 180, you're subtracting 145 to get to the answer. Okay? So let's do these together. Let's see. I've got a triangle. I got two angles. We're supposed to add these two and subtract from 180. Let's see. 60 and 60 is 120. So 5 less than 120 is 115. So 60 plus 55 is 115. So I simply need to subtract 115 from 180 to get to 65. Second one, well, let's see, 25 and 90 would be 115. Oh, it's the same problem. 115 from 180, 65. Am I losing someone? Okay, good. Last one, notice there's no measurements. So what you need to remember that for an equilateral triangle, that the angle measurements are 60 each. In other words, all three angles are 60. So they're all the same. So you get three of them. 180 divided by 3 is 60. So therefore, all the angles are 60 there. Does that make sense? Notice I didn't have an X here, but I should have had an X.
So if you had an isosceles, it's like only two of the sides were the same, and you were only given one, you can figure out, depending on where it is, you can figure out which each one is, correct?
You
Because
can. Regardless of whether you're given the one that isn't the same as the other one or one that is the same as the other one. And I'll show you that here in a couple slides. All right, one more time. Let's see, 90 and 30 is 120. 180 minus 120 is?
60.
That's a pretty easy one. We can do that one in our head. This one, let's see, 110 and 35 would be 145. 180 minus 145 is?
35.
So here's an example, Jaden, of an isosceles triangle, 35, 35, 110. Okay, so if you have already forgotten this, I do want you to remember that for all equilateral triangles, all the angles of an equilateral triangle are 60 degrees. Why? Because all three angles are the same. And 180 divided by 3 is 60. Okay? For an isosceles triangle, it turns out that only, guess how many angles are the same? For an isosceles, guess how many angles are the same? Two. And they will be the two angles that are opposite. In an isosceles triangle, we call these the legs. They will be the angles that are opposite the two congruent sides. In other words, opposite the two legs. So if this one is 25, then this one is?
25.
25. Okay?
And that's what I was saying. If you get one, then you can tell what the other
And
is.
it doesn't matter which of the three you get because the other two would have to be the same.
Right. So if you get the one that is across from the leg, you can figure out the other one. You add those
And if
together.
you're given this one,
from 180.
and then
Right.
divide
You
by
subtract
2.
it from 180, and then you can get there.
Correct.
So you can get all of them just by having one that is across from a leg.
Right. All right. So 180 or subtract 50 is 130. Therefore, the last angle right here would be 30. Okay. Or sorry, 130. All right. So the new game is I gave you an isosceles triangle. You got to figure out the other two. If this one is 28, then this one is
28.
28. And then to find the third one, you simply add 28 and 28 and subtract from 180. Okay, if I'm going too fast, please slow me down. 28 and 28 is 56. 180 minus 56 is 124, I believe. And yes, it is. Okay, questions? All right. It can also work, this is what Jaden was saying before, if I give you this angle. Notice this angle is not the same as this one or this one. It's not the angle that is opposite the two congruent sides. But since I know that this angle right here and this angle here are congruent, I can still get to the answer. So I know that this one is x and the other one is x, because it's an isosceles triangle, they're the same. So all I need to do is simply combine like terms, x plus x is 2x, and solve that equation. Or in other words, subtract 124 from 180, right? And that gives me 56, and then divide 56 in half. In other words, divide both sides by 2, and we get 28 degrees. So this x is 28, and that x is 28. So there are, I'll go back to the previous one. There is an example of where we're given one of the congruent angles, and we can solve for the third one. And here's an example of where I'm given the third one, and I can solve for the other two congruent ones. So both of those are done similarly, but not the same. Questions on that? Okay, we better do one. All right, so here we go. I'm given that this one is 40. If this one is 40, this one is
40.
Okay. Therefore, to solve for the other one, we add these two and we subtract from 180. So therefore,
100.
the third angle is 100
100.
degrees. Very good. Okay. On this one, same process. We know that this angle and this angle are the same. Therefore, I would get 2x plus 115 equals 180. Okay, this is an extra step there. 180 minus 115 is 65. And oh, we're going to get an ugly
32.5.
32.5. There we go. All right, that's how we handle isosceles triangles and interior angles. Questions? All right. The last one is, we'll call it the last game here, is, oh boy, does it get complicated. All right, so you'll be given a shape. It's going to be a complex shape, meaning like it's not just a triangle, it's something else. Looks like an hourglass. And you'll be given a bunch of variables, x, y, and z, and you'll be asked to solve for each one. So I'm going to try to show you in this one example every single possibility that you will see. Generally speaking, you will see triangles. We know that the sum of the interior angles of a triangle are 180, but notice on this one, I'm only given one and it's not isosceles, so I can't solve for the other two. So just this bottom triangle right here at the start, I can't do anything. But what I can do is something to the top one. And notice on the top one, I have two of the three angles. I can figure out what z is. All right, 70 and 30 is?
100, meaning z would be 80.
Meaning z would be 80. Okay, so z was the easiest one. To do the other one, we got to use some of those other skills that we've learned. And you may not see it immediately, but I want you to look right smack dab here in the middle. Does anybody see the shape right smack dab here in the middle?
They're vertical angles.
We got an
meaning they're
X,
congruent.
and therefore we have vertical angles. So if this angle is 30, angle Y has got to be
30.
So that one's the easy one. So vertical angles are congruent, therefore y is equal to 30 immediately. Now on the bottom triangle, I have two of the three. I can get to the other one. So 30 and 75 is 105. Therefore, x is
75.
It turns out that the bottom triangle is an isosceles triangle. It just wasn't marked that way. Okay, cool. Here's a second complex shape. This is where it gets really, 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 really complicated. Complex shape right here. Well, it looks like we have two triangles. I guess some of you might say you see three triangles, two small ones and one big one. Okay. Geez, how are we going to solve this one? Notice the one on the right, we only have two of the angles. Oh, but look at the one on the left. What kind of triangle is it?
Isosceles.
Therefore, if this is 25 then that
This
is
is 25.
right. And you got to be careful isosceles. Remember, it's the angles that are opposite the two congruent sides that have the two congruent angles. So therefore, I don't know what z is yet, but I do know that since it's an isosceles triangle, but that angle is 25. And now check it out. 25 and 25 is,
50, meaning z would be 130.
everybody get that? 25 plus 25 is 50. Therefore, subtract 50 from both sides, we get z is 130. Okay, z is 130. That doesn't help us with x or y, or does it?
It does, because you... Me stop?
Yeah.
Z
No,
and Z and Y are alternate interior angles.
no, we don't have parallel
Yeah.
lines, but they could be if there was a parallel line up here, but there's no
So-
parallel lines.
Z and X are on a line, so that's
Oh.
180. So then that means X is 50.
Can you guys see that? That z and x form a straight line at the bottom there. Therefore, they're supplementary. We call them linear pairs, two angles pair that make a line. Therefore, they're supplementary. Therefore, 180 minus 130, 50 degrees. So now we know that x is 50 degrees. 130 plus 50 make 180 degrees. See the line here? Make a nice straight line. Now I have two of the three. Therefore, I can find the third one. 50 plus 45, 95. Therefore, 180 minus 95 is
Y
85.
would be 85.
Sorry, 85, not 185. Okay. I think I gave you basically all the answers for homework with those two examples. This one right here and this hourglass one. I think those are the two ones that you will have the most challenging or most problems on. So this one right here, we got the fact it was isosceles, so the opposite angles to the congruent legs are congruent. And then on the hourglass one, we had vertical angles. Okay. Any questions on anything we did? Oh, by the way, Jace, so you know, if this side of this triangle was congruent or was parallel to this side, then we would have alternate interior angles between this angle and x. But that would only be true if this side of this triangle was parallel to this side. Then we would have both 70 would be congruent to this, and this angle would be congruent to that angle. Okay, and you will see that in high school lots of times. We don't really use that much in pre-algebra. All right, any questions on anything that I did today? That was kind of a quick class, but it was on triangles. 16 is the challenging one. Good luck on that. Questions? Nothing? Okay. Well, we'll call it a day right there. Just remember, I'm going to post the class by 4 p.m. So if you need to watch it again, and don't forget to do your quiz. Do your quizzes, 10 minutes. All right.
Okay, I will.
Catch you guys tomorrow.